Alright, in this video I'm going to show you how to find the continuity of a piecewise or a rational function. So generally, from a graph, it's a little easier, but if they just give you an equation, it can be kind of difficult sometimes. So we'll do piecewise first. So imagine your teacher gives you a problem, something like this. Okay, this is what's considered a piecewise function. And what that means is there's multiple pieces to the actual graph. So for instance, like if you imagine a graph, you might have one section of line doing something like this, and then there might be another section of line that does something like that. It just kind of depends on what equations they give you. But what we're looking for is continuity. So if you remember, there were three types of discontinuity that we've talked about before. So that would be a removable. That's where if it's just like a hole in the graph. There's also a jump. That's where if there's actually like a jump in the graph. And then there's an infinite. And infinite is generally around an asymptote, and you can have both the arrows going the same way or going opposite directions around an asymptote. That throws you an infinite discontinuity. Infinite is generally associated with rationals. But let's look at this first problem here. When you approach a piecewise function, the first thing you need to do is look at where your breaks are. At x equals 1, something's happening. So I need to figure out what is possibly happening. It could also be continuous. I just have to kind of find out for myself. So when you approach a piecewise function, the first thing I like to do is I like to plug in the number where this thing is happening into both of these equations. So if I do that, at 1, I get a value of 0. And at 1 here, I get to value of -1. So if you imagine I've got one side where I'm at 0, and then one side where I'm at -1. Well, to me, that looks like a jump. So in this first piecewise function, at this location, there's a jump. And honestly, I think the best way to learn this is to kind of just go through a bunch of different examples and see for yourself the different types. So imagine this problem. This is going to be another piecewise. Okay, let me clarify something. If on this first problem, when I had plugged both of these in, if I had gotten the same number, like say 5 and 5, it would have been continuous. There would not have been a jump there. But look at the difference between this first problem and this second problem. This first problem had an or equal to, meaning at 1, it was covered. It was part of your domain. But look at the second one. 0 is not part of your domain. So it cannot be continuous. Now I just have to find out if it matches from this guy to this guy. If when I plug it in, like I did on that first problem, if those output values are the same. So if I plugged in 0 here, I would get -1. If I plugged in 0 here, I would get -1. So these things match, but at this location, 0 is not part of my domain. So what that means is you have a removable discontinuity here. And by the way, whenever you label discontinuity, you really need to say where it's located. So like this first one, I would say jump at x equals 1. And the second one, I would say removable at x equals 0. So again, If it's part of your domain and they don't match, it's a jump. If it's part of your domain and they do match, it would have been continuous. If it is not part of your domain, it cannot be continuous. It either has to be a removable or a jump. Okay, look, I'll show you one more piecewise that'll kind of clarify this whole thing that I've been trying to talk about here. So imagine this problem now. Okay, when I look at this problem, the first thing I see is that 1 is part of my domain because it's got an or equal to there. So I know it's possible that it could be continuous, but it could also have a jump. It just depends. I have to check by plugging in this 1. If I do that, I get 6. Plug in this 1. If I do that, I get 6. So see how these match and 1 was part of my domain? This is an example of a continuous function. All right, before I move on from piecewise, I just want to clarify because it can get really tricky. When you plug in both of those numbers, if they match, they have to match, and it has to be in the domain, so it's covered by an or equal sign, it is continuous. If they match, but it's not in the domain, so neither one of these things has an or equal sign, then it's removable. And if they don't match at all, it's a jump. When they don't match at all, you really don't even care if it's in the domain or not. It's automatically a jump. Now let's look at some rational. Okay, the first rational I'll start you out with would just be something like this. For a rational function, you want to focus on the denominator. That's going to tell you where your discontinuity is located. And for a rational, it's probably either going to be an infinite discontinuity or a removable discontinuity. So I'll show you how to tell the difference. If you factor everything and nothing cancels, like in this one, I didn't have an x up here that canceled. So in this one, the x is on bottom. Basically, you want to take whatever's on bottom when it's factored and set it equal to 0 and solve. This is where your location of your discontinuity is going to be. And if you didn't cancel anything out, I'll show you what I mean by that as well. But if you didn't cancel anything, it's going to be an infinite. There's going to be an asymptote there. I'll show you another example. Imagine this one. Okay, when I see this problem, I'm immediately factoring everything. So I GCF the bottom, and now when I look at it, I see 2x minus 5 would cancel. When this happens, that's an example of a removable. It is not an asymptote there, it's just a hole. And to know where that hole is, again, take whatever you canceled, 2x minus 5, and set it equal to 0 and solve it. So I would have a removable at x equals 5/2 for this problem. So if it cancels, it's a hole, it's removable. If it does not cancel, it's an infinite discontinuity, it's an asymptote. I'll show you one more. Imagine this problem. Whenever I see a rational in general, I'm factoring everything. You can learn a lot about a rational function just by factoring it. So in this one, the top would become x minus 2, x minus 3. And then on the bottom, it's x minus 3, x plus 3. So the first thing I see is I've got x minus 3's that cancel. That's going to be a removable. And remember, you're supposed to set it equal to 0. So this one's going to be a removable at x equals 3. But then I also have a factor on bottom that did not cancel. So this is going to be an infinite discontinuity. And you're supposed to still set that equal to 0. So I know I have an infinite discontinuity at x equals negative 3. That means there's a vertical asymptote at negative 3, and there's a hole at positive 3. So I hope this helped. These things can get really tricky. So I suggest practice, practice, practice.